and this smaller triangle. These two triangles we are focusing on. Okay, so we'll see the similarity between these two triangles. First is C. Two common properties are sufficient to draw up the similarities. This is the common side between both of them. So side is there. And apart from it, these two angles will be equal because they are vertically opposite angles. So using side angle property, the triangles will be equal to each other. Okay, so not equal, similar. Similar is different, similarity of triangles is different, and equality of triangles is different. When we say triangles are equal, means all the dimensions are same. Similarity means you can take their ratios, the denominator by the numerator by the denominator. For all the triangles property, they'll be the same. Like if I say ABC triangle is similar to A dash B dash C. Though all these things you've already studied till your 10th class, this is just a usage of what you have studied. Nothing new is here. So if I say ABC is similar to A dash B dash C, then I get the authority to write AB by A dash B. A dash B dash I means the same similar sides that we have taken. Similar, same in literal terms also they are different. Same means exactly the replica. Similar means properties are similar. So it means I can take this side by this side equal to. Then let's take BC by B dash C. BC, B dash C. Means this side by this side equal to this side by this side. Means whatever are the similar properties of from the triangle, those we can take. This is how we write the similarities of the triangle. We use it whenever two triangles are present. I hope this is recalled, though this was there in your lower classes, but still it's been a long time. So I hope the similarity is now recalled by everybody. This is how we use, okay? Whatever are the common sides, we'll apply the rule like this because similarity will be used further also. That's why I'm saying. So is the similar concept clear? Like if the triangles are similar, how can we write it? Is this much clear? Then only I'll move further.
Yes, ma'am.
Okay. So see, if we have the triangles, these two triangles are similar. So see, we can say A dash B dash by AB is equal to CB dash by BC. Whatever I wrote, I think I wrote AB above BC above. This has just been reciprocated. So this is it. Now see, why are we writing this? Because this is a derivation. We already know the confusion. We are deliberately using the whole concept of similarity of triangles in order to extract the formula that we already know. We are just proving it, okay? So don't think that how will we apply this in the exam? It is very difficult to identify the similarity of triangles. You don't have to know where it will be required. This is just for the derivations. And see, after one or two practice, you will be able to remember it for the derivations. And this won't be just used for the derivations, whether it's lens or these are the mirrors. The CB dash, when I talk about, look here. If I talk about this CB dash, smaller one, so see CB dash is nothing. Let me mark few things from in this question so that it is a little visible to what we need. AB is the object in front of the mirror, and I have told you everything is measured with respect to the pole of the mirror. So I can say that from the pole to the object, this is known as the object distance, which is u. BP is equal to u. And that too, we will put minus u according to the sign convention we studied. What was the sign convention? Anything in front of the mirror is negative, anything behind the mirror will be positive. Object is always kept in front of the mirror, so it will be negative. So this is the object distance, which is BP, which will be written negative. U will be negative here. Next, what else is required by us? From the pole, this is the image. Here the image has been formed. A dash, B dash, this is the image that has been formed. So from the pole of the mirror to this image, this becomes the image distance V. Now this image has been formed in front of the mirror. So again, this will be negative. For the image to be positive, it has to be drawn or formed behind the mirror. So V will also be negative in this case. That's why minus U minus V are mentioned. Focal length for a concave mirror is always negative. For a convex, it's positive because focal length lies in front of the mirror. Whether you reciprocate the mirror, means reverse the mirror, or you take the mirror in this manner, focal length will always lie in front of it. And for convex, it lies behind. So convex, it's positive. Focal length of concave will be negative. And do the derivation using concave mirror only. Just in case if a question specifies you to use convex mirror, then you only use convex. Otherwise, go for concave. For lens, go for convex. For mirrors, go for concave. Try to remember this because these things are easier in comparison to the other two that are present. Okay, so this is image distance V. V is representation of the image distance and U is the representation of the object distance. Means the standard representations. What else do we need? Yes, from the center of curvature to the pole. All these points we have discussed, this is the radius of curvature. In this case, nothing is behind the mirror, so all the things that I am marking will be negative. And half of the radius of curvature we studied in the last class, we in fact derived also. So half of the radius of curvature is the focal length, that is f. All these things will be negative because of the sign convention. Everything is lying in front of the mirror, but these are the markings and we have to find out everything in terms of these. Am I clear with the terminologies to everyone?
Yes, ma'am.
All right. Now see, regarding the points that we have obtained, it is coming CB dash. Now look, CB dash is nothing from the figure. It's neither U nor R nor F nor V, nothing. We need at least the terms out of these so as to derive a formula, because this is a derivation. We are not randomly doing anything. And anyways, we'll have to find out standard things. So what we do, we try to write it in terms of those which are visible to us, which we know. Now look, PC, this is the radius of curvature. This B dash P is the image distance. So if I subtract from this bigger, this one, I'll get this one. I can say CB dash is equal to CP minus B dash P. And why did I choose that? Because CP is the radius of curvature and B dash P is the image distance. Similarly, the other, this CB which is left, the CB also nothing according to the figure. So what we can do, if we write it in terms of the things that are again visible to us, like this we know is the object distance. This we know is the radius of curvature. So object distance, radius of curvature, if we subtract the leftover portion, we'll get BP minus CP. Now I can say CP is minus R, B dash P is minus P, BP is minus U. And now I can easily put up the values in here. CP is minus R minus B dash P is minus V. The sign conventions have to be put apart from this negative sign. These are from the formula. Bigger minus smaller one. This is not the sign conventions. Sign conventions have to be applied. Divided by BP is minus U minus CP is minus R. So what do we get? V minus R by R minus U. First tell me, till here have you all understood each and every part?
Yes, ma'am.
Others also?
Yes.
Okay, Ali, okay, Ubaidullah, Anisa, Halima, fine. Oishi, to you?
Yeah, understood.
Oishi, since you have joined from today only, your optics portions have been missed. So please take up the video lectures also. And if you're not able to understand anything in today's class, which can be learned from the previous classes, please point it.
Yeah,
Okay?
what did you teach in the previous class? Just like a gist. Not much of the portion was covered, I guess, right?
Yes, not much of the portions were covered. Basics of it, I think 2 classes were done.
Only
So one,
laws of reflection and all were covered, I guess.
yes.
Okay.
That reflection,
Yeah,
laws of reflection part and all are covered. Sign conventions we did, the basic ray diagrams we did till there. And one derivation we did for the focal length and radius of curvatures relation. So that are, those
okay.
portions are easy. I'll share the notes with you, Ishi, because if in
It's
that
okay. No,
batch,
it's okay.
okay.
If I need anything, I'll let you know.
Yeah, please let me know. So this is it. Now we need further. So what we'll do, this triangle only we'll take. This A, P, B and A dash, P dash, B. I'll just mark it so it is a little visible. Look, this big triangle, because of which we had applied the third law also. We didn't need that. So this one and this one. Now look, again this becomes the common side. And angle of incidence is equal to angle of reflection according to our laws of reflection. So these two triangles, this one and this smaller one, these two are also similar. So why do we need that? Look, again we can say from this, I can say A dash B dash by AB is equal to B dash P by BP. What is B dash P? B dash P is minus P. What is BP? That is minus U. Now, this term is equal to A dash B dash by AB. Term was also equal to A dash B dash by AB. It means I can equate both of these. Right, this is V minus R by R minus U. V minus R by R minus U equal to this term V by U. This is equal to V by U straight away. Now look, now this we just have to resolve, just simplify, and the answer is there. That's all. This is what you need to understand. If you are done with this step, afterwards you'll be able to understand easily. Let's just cross multiply this. This will be UV minus UR is equal to VR minus UV. UV goes on that side. UV plus UV. This will be VR plus UR. This becomes 2UV is equal to VR plus UR. What we do? Divide by UVR. Like if we have the equation 2UV is equal to VR plus UR. Let's divide this by UVR, UVR, URV. Same thing. So this will be C. UV will be cancelled. VR will be cancelled. UR will be cancelled. What are we left with now? We are left with 2 by R is equal to 1 by U plus 1 by V. Now we have already discussed that focal length is 2 by R. R by 2, so 2 by R will be equal to 1 by F. So I can finally say 1 by F is equal to 1 by V plus 1 by U, which is a formula from your lower classes also. You have done this in 10th. So if you remember or not, now you have to remember. Okay, and this F is what? This is your focal length. So all the things are mentioned initially too. Focal length, V is the image distance, and U is the object distance. Now, one more thing, class, just remember this carefully. So even if I forget to mention in any other class, in ray optics chapter, only in the topic optical instruments, you have a topic optical instruments, microscope, telescopes and all. Only in that topic, you do not use the sign convention. Otherwise, any other formula, mirror formula, lens maker formula, apparent depth formula, any formula that you have, you'll have to apply the sign conventions. Only in optical instruments, you do not have to apply the sign conventions. Okay, so here also use sign conventions. Means, see, we have included the sign conventions here also. Apart from that, you need to include the sign convention, then only you'll get the correct answer. And it's very helpful. This formula is very helpful in mirrors also and in lens also. Magnification I'll discuss later. First, all of you copy it till here. And this derivation is asked in the exam. Mirror formulas derivation especially asked. Magnification is least asked. When numericals on magnification is asked, I'll tell you what kind of questions come. First, write it, all of you. Done by all?
Yes, ma'am.
Okay, let's complete this. Coming to linear magnification, see what is linear magnification? It's basically the ratio of the height of image to the height of object. I'll write this also. Ratio of height of the image to the height of object. To the height of the object. Now, height of image, remember we have discussed that from the principal axis we take the height of the object or image, whatever it is. What you do, the same triangle, the angle of incidence and angle of reflection one, APB and A dash PB dash. Till here we have already seen how this has come. And we also wrote that this is minus V by minus U is equal to V by U. Just this step. Plus, just in case if you get a question with the proof of linear magnification only, then you'll have to redraw this figure. I am not redrawing it. You have to redraw in the exam if it comes this. And then you have to show that these two triangles are similar. That's why you're writing this. Okay, because without figures, don't just directly write it. In the test also, test papers also, I'm checking. You people are just skipping up the steps. Don't skip the steps here. So see, this is V by U. Now see, height of image. Image is found below the principal axis. So height of image, that is A dash B dash, will be negative. And object is put above the principal axis. So height of object will be positive. B dash P is minus V, BP is minus U, as we've already discussed. So when you equate both of these, V by U is equal to minus height of image by minus height of object. Actually, the formula can be written as magnification is height of image by height of object. So minus sign goes over this side, that becomes minus V by U. Remember this because in length, this minus sign will be vanished. So magnification is height of image by height of object, which is further equal to minus V by U put in the sign convention. So what's a magnification? Ratio of height of image by height of object is known as linear magnification. When you take the heights of object and image, that is linear magnification. One, you have transverse magnification. Transverse magnification means if you take the length of the image, or it is if the object is put transversely. So that is transverse magnification. This is denoted by the symbol M. Okay, there are a few more points that I want to discuss in magnification that I'll tell you. First, you write down this much part and write it somewhere in your notebook that if the question comes only on linear magnification's derivation, you have to redraw the diagram. Redraw what? You have to draw it in the paper properly. That diagram you have to show, and then you have to show that these two triangles are similar because of right angle problem. Okay, don't just write directly like this. Okay, usually linear magnification isn't asked, but you should be prepared for everything. Write it down, then few more things about linear magnification I'll discuss. Most of you have given the assignments of AC. Till transformers, last one is left. Transformers assignments are left and this EM waves assignment is left. So Ali, I think, is giving the assignments regularly. Ali, just write down all the steps properly. Some questions you didn't attempt, I'll discuss those questions which you found trouble in. After this topic, completion of this, I'll discuss because it was in a continuous manner. So that's why I didn't discuss the assignments in the starting of the class. I'll discuss. EM waves, nobody has touched yet. So it's okay, first complete the AC ones. Transformers share, EM waves also share. Ubaidullah, your assignments, you have to start giving the assignments properly. And Anisa, I haven't received a single assignment of yours. If you go in this manner, you'll face a lot of trouble because at least this gives me an idea how you people are writing in the answers. Write the steps properly. And Ali, please do the assignments more sincerely. Like you are doing it. That's very good. You are the one in this batch who is attempting those assignments properly. But attempt the questions with a little more sincerity. Don't just attempt whatever you are able to do. Even if some questions you aren't able to do, at least try till few steps. That will give me an idea. Okay, you lagged at this step. This part was missing. Okay, and this is for everybody, not just for Ali. At least he's attempting the assignments. Rest of you are not even touching it. So Anisa and Ubaidullah, you have to start giving the assignments. It's a high time now. Ubaidullah, you have given few, but you are not regular with them. And Anisa's not a single assignment received. Please do it. Today I'll be discussing the assignments of AC because like this, many assignments have been piled up. EM waves, I understand it was done recently, but AC has been over a long time back. So please share those. And Transformers one, at least by tomorrow, share so that in the next class, this AC chapter is also gone and EM waves is touched. Okay, write down this part, and I'll discuss the magnification further.
Can you scroll up on my time complete? Okay, ma'am. Done, ma'am.
Ma'am, length means U and V.
No, see, length means if I say U and V are the object and image distance, that will be there in the case of length also, height also. This means, let's say if I have a mirror like this and I put the object like this, okay, in a transverse manner. Horizontally, if you're keeping the object, image, let's say image I'm obtaining like this. So this length of object by the length of image, okay, instead of height. Clear?
Yes.
Done?
Yes. Yes.
See, what I wanted to discuss about magnification was that, see, magnification is a very helpful quantity to find out the nature of the image without seeing the ray diagram. How? What you do, you see what's the magnification is given to you. Before that, one more thing. If you use this formula, no, V by U, and just in case if you're provided with focal length and one of the quantities and one of these is missing, means if I say, let's say we have the focal length given and the object distance is given, image distance is missing. So what you can do usually using the lens, using the mirror formula, 1 by f is equal to 1 by v plus 1 by u, you calculate the value of 1 by v and then put it in this formula because v is missing. When you will solve, you can easily get this f by f minus u. So you can use this formula also. Similarly, if image distance is given, focal length is given, object distance is missing, then use f minus v by f. This formula. The next thing that I was telling you was regarding how to identify the nature of image and the size of the image. First, you calculate its magnitude. Let's say I have the magnification as -5. Okay. You take its magnification and let's say 1 is plus 0.5. First, you take its magnitude. Magnitude means just the number without any signs. Means -5 will be just 5. Plus 0.5 will be only 0.5. Then you see, is it greater than 1? See, if it is lesser than 1, means image is smaller, diminished. If it is equal to 1, magnitude is equal to 1, exactly of the same size. And if it is greater than 1, then enlarged image. This is how you are going to check. Forget the signs because -5 will be less than 1 then. And 5 is greater than 1. So your answer will be exactly opposite. So what you have to do, you just have to take the magnitude of the magnification. Take the magnitude of the magnification. So what if it is less than 1, it will be diminished. If it is exactly equal to 1, so image will be exactly of the same size as that of the object. And if it is greater than 1, then enlarged. Now, what do we do with the signs then? Signs will tell you whether it's virtually erect or real inverted. If the sign is negative, then real and inverted, because of course it is formed below the principal axis. And if it is positive, then virtual and erect. So by calculating the magnification, you will get the rest of the details. Now, what kind of questions come? One of the questions I'll practice with you today itself. These kinds of questions have come a lot in the board exams from this. Actually, a lot. So the question will be usually object distance is given to you, focal length is given. Find the position, nature, and size of image. This is a very common question. Position, nature, and size of image. This means position means where is the image formed. Means you have to calculate image distance v using the lens formula, using the mirror formula. Sorry. Second is size, magnification's magnitude. The nature, the sign of the magnification. So this is how the questions are framed. I'll discuss one of the questions also with you. This one, this is from your NCRT only. Let me discuss it. The first part I'll be discussing. Second, the values will be just changing that you will do, and you will tell me what is your answer coming. This says that an object is placed 10 centimeters in front of a concave mirror. Means this is a concave mirror and an object is put 10 centimeters in front of it. So what is this 10 centimeter? R, F, what? Tell me.
U.
U. Very good. Yes. So, and it will be positive or negative?
Negative.
Negative. Very good. So this is minus 10 centimeter. This is in front of a concave mirror of radius of curvature. R is given to us as 15 centimeter. Now, focal length is half of radius of curvature, because radius of curvature you don't need in this. So 15 by 2 will be 7.5 centimeters. So focal length will be positive or negative, class?
Negative.
Negative. Yes, very good, Abedullah. So focal length will be negative. So focal length and object we have. Now this question says the same thing. Position, nature, and the magnification. Magnification basically means the size, nature will be given by it. So what you do, 1 by f is equal to 1 by v plus 1 by u. So from this we can say 1 by v will be equal to 1 by f minus 1 by u. So if we put in the values, my 1 by f, this is minus 1 by 7.5, minus object distance is minus 1 by 10. That makes it minus 1 by 7.5 plus 1 by 10. So V will be equal to 7.5 into 10 by minus 10 plus 7.5. So that is 7.5 into 10 by 2, minus sign will also come, 2.5. So this makes it 3, minus 3 into 10 is minus 30. So image distance is coming minus 30 centimeter. Whatever you get, you have to use this knowledge to calculate your answer. That's why I say put the sign conventions from the starting. You'll get the wrong answer then. This means that, see, minus 30 centimeter, minus sign clearly shows that image is formed in front of the mirror. Okay, minus sign tells you, this basically tells you image is formed 30 centimeters in front of the mirror. Exact location, position of image is clarified from the image diagram. Other things are left. So this is 30 centimeter in front of the mirror. Means if this is 10 centimeters, so the ray diagram would have looked like somewhat like this. Then from the center of curvature, here the image would have been formed, and this separation would have been 30 centimeter. and this would be the image here somewhat. Okay, now magnification. See, magnification will be minus V by U minus image distance is minus 30. Object distance is minus 10. Minus minus sign will cancel, 0, 0 will be cancelled. Still, the magnification will come out to be minus 3. Now see, what did I tell you? What do you check first? You see the magnitude. Magnitude of magnification is 3, which is greater than 1. Therefore, image is enlarged, and that we could predict from the ray diagram also. Second, this is now the negative sign. Negative sign just tells you the fact that the image is real and inverted. So finally, what do we have? An image of magnification minus 3 means the complete answer would be image is formed 30 centimeter in front of the mirror, which is enlarged, real and inverted. So finally, you can even conclude this. I'll just write it here. Therefore, your final answer will be an enlarged, real and inverted, real inverted image is formed 30 centimeters in front of the mirror. This is how you have to write these questions. Try with 5 centimeter and tell me the answers also. And before that, tell me, is it clear to each and every one?
Yes, ma'am.
Only Ubaidullah and Ali.
This will
Clear, Halima, Anisa? Please write it and try to write the answers in this manner. And if you have time, try to draw the proper ray diagram if you are left with time in such questions. If not mentioned and you are lacking the time, leave. But like this, just draw a rough diagram, just showing images here, object is here, just specifying few things. Like you can just specify focal length will be somewhere here and on. Okay, because it is 7.5, so here this will be the 7.5, something like this. You can specify if time is left. Okay. Please write it from here. And if you have any doubts in between, please ask. Done.
Yes.
Class, in this, I think the rest of it you were all able to attempt properly. Third question you had a little trouble with. Let me discuss this. See, this question says figure shows how the reactance of an inductor varies with the frequency. Calculate the value of the inductance of the inductor using the information of the graph. See, you have the frequency, you have the reactance given. It means XL is given to you from this side and the linear frequency is given. So you already know a relationship. XL is equal to 2 pi nu L, right? So the question says calculate the value of inductance, means L is to be calculated, XL and frequency have to be extracted from the graph. You choose anything, any value, let's say 4. What's the corresponding value of the frequency? 200. You can choose any because the graph is very clear. So this will be 4 is equal to 2 pi into 200 into L. This will be 400. Inductance will be 1 by 100 pi Henry. This will be the answer for the first part, okay? Second says if this inductor is connected in series to a resistor of 8 ohms, what would be the impedance at this? Means resistor is there and reactance of inductor is only there. Means RL circuit, LR circuit we did. So inductor and resistor, they are connected. It means you need XL and R. So what XL are you going to pick from this? Set frequency 300. So for 300, look, XL is given as 6. So this is 6 ohm. Now you know how to calculate this. Under root 6 whole square plus 8 whole square, that is 36 plus 64 under root, which is root 100, that is equal to 10 ohm. Okay, so this is how this question had to be done. Most of you didn't attempt the second part also. Okay, so I hope now it is clear. And this everybody did well. Those who have submitted, they have attempted it well. Those who have not, please see what all assignments you have to give still. And in this question you all had a trouble in. The second question, it's a question where XL and XC are equal to each other. So this says what will be the readings of voltmeter and ammeter, means current you have to find out. See, this is the clear case of resonance. XC is equal to XL, which is equal to 4 ohm. Means impedance will be equal to the resistance, that is 45 ohm. Okay. When impedance is given, voltage is already given as 90 volt. This voltage. So current will be voltage by the impedance, that is 90 divided by 45, that is equal to 2 ampere. It says voltmeter. Now see, when you calculate the difference between their voltages, voltage will be calculated across these two, right? Because voltmeter is connected here. You have to see where is the voltmeter connected. Ammeter was connected just beside this. Voltmeter is connected here. So only these two will be included. So since their current is there, what will be their voltages? Current will be the same because it's current. It is connected in series. So voltage across capacitor will be I into 4, and voltage across the inductor will also be I into 4. Net voltage will be 0. They'll cancel each other. This was the answer. Okay, this also you all did it well. I think Ali, you didn't attempt the third one. Second was incomplete. Third, I think it was left. All right. So if anyone has to write anything from this, please copy if you want. Otherwise, see, now your plane mirrors are left. The circular mirrors are over, spherical mirrors. So plane mirror is a small topic. So that will be done in the next class, and I'll be starting with the refraction in the next class itself. Okay. So on Thursday.